All right, as you begin watching this video, you're going to see the answers. So if the sub would please pause this so that you can correct and check your worksheet. You can go to this page, pause it once everyone is ready. This would be the next page that you are correcting. So to make sure you're checking your worksheet from yesterday on lesson I1, the worksheet. And now we're going to begin the lesson. And again, if you check, these will be on the notes online, so if you need to take a look at these notes, the answers will be provided on the notes attached to the daily planner. So one of the things now that we are taking a look at is, can we sketch a quadratic? Can we identify the x-intercepts, which we know are on the x-axis, the y-intercept on the y? Is it an increasing or decreasing? Is there a maximum? Is there a minimum of our function? And we need to be able to explain the minimum and maximum in our quadratic, that is actually going to be our vertex. And identify the vertex, and that this will be our minimum or maximum. So first off, one of the things we have to look at in the previous lesson, we worked with our quadratic equations, had no middle term. So we didn't have a bx before. Today we're going to look at quadratics that have that middle term. So before we had ax squared plus c, it was a lot easier to look for that point of our vertex, and as we are looking at those. When we have this middle term, it says in a quadratic function, if we are taking a look in a quadratic function, one of the things that we will see, ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. So this is our axis of symmetry that we are looking at. Remember, it always goes through our vertex, so when we are looking, here is our vertex down at this point, and we looked at our vertex. What is our x equal to? That the vertex, it was down at negative 1 half, and x is a vertical line. Here our vertex is at that point where x is negative 1, the axis of symmetry. Remember, that's just our line, and it's always vertical. So it says, notice that the changes in the b value in the equation of the axis of symmetry is related to the ratio b over a. So in our first equation, 2x squared plus 2x, b divided by a is 1. And our axis of symmetry means that x is equal to negative 1 half. So this is an important concept that we kind of want you to look at. We look at b divided by a, and it was 2, and our answer was negative 1. And in this equation where we had 6x, 6 divided by 2 is 3, but it's written as 3 over 2. So an equation for the axis of symmetry is always going to be equal to a negative 1 half times b over a. And a lot of times you're going to see this written as, and I'm going to write it back over here, and this is the important part that we are looking at, x is equal to negative b divided by 2a. This is also going to be part of when we are solving towards the end of what's called our quadratic formula. But right now, that negative b over 2a is what helps us to find our axis of symmetry. Yes, you want to memorize this. You want to make sure you understand that that's your x point. So as we are taking a look at our equation, one of the first things we want to be thinking about as we look at our equation is, what are our different values? So remember, standard form for a quadratic is ax squared plus bx plus c. So what is our a value? Our a in this equation should be a negative 1. What is our b? b is 4, and c is a negative 2. So if you can kind of identify those, now using this formula, x is equal to negative b, so negative 4 divided by 2 times a negative 1. So x in this case is actually going to be equal to negative 4 divided by negative 2, which equals 2. Which means my axis of symmetry is going to be the equation x equals 2. That's a vertical line at x is equal to 2. Next thing we want to find is, what is the y coordinate of this? So we go back to our equation, our original equation up here in black, and we are going to substitute in x. So we have negative 1 times 2 squared plus 4 times 2 minus 2. And if we are solving this, this is 2 squared, gives us a negative 4 plus 8 minus 2. So our y value is actually going to be equal to, this would be a positive 4. 4 minus 2 gives us 2. So where is our vertex? Now remember, our vertex is an ordered pair. It was located at the point 2, and we solved for y and found it was at 2, 2. So we now can put a point at 2, 2. It says we need to find 2 or 3 other points on our graph, and we're going to use the line of symmetry to our advantage. So keeping in mind, this is our line of symmetry, which means it's going to be the same on both sides of that. So if we are looking at an XY table, and we know that the vertex is 2 and 2, we're going to go to 1 and 0 and pick 2 numbers on this side. And then what we know is it'll be symmetric on this side. And if you're not sure, you can try 3 and 4, but you should see that those are going to work. So we are going to go back to our original equation at 0 and plug in 0 for x. If we are doing that, that means we're going to have y equals negative 0 squared plus 4 times 0, that's still 0, minus 2. So at 0, we are down at the point negative 2. What happens when we replace it with 1? You have negative, you're going to take 1 squared. Minus 4 times 1, minus 2. And again, if you need to pause the video to write this down, make sure you do so. You have a negative 1, because you're squaring it first and then taking the negative, minus 4, so we're up to a negative 5. If we are looking at this, and then we have minus 2. So if we are taking a look at plugging in 1, and it should be 4 times 1, so that's going to be a plus 4. Got to make sure I write the equation correctly. So negative 1 plus 4 gives us 3, and 3 minus 2 gives us 1. So when we plug in 1, we get 1. Now, what should happen is if I plug in 3, I should also get 1, and if I plug in 4, I should get negative 2. And what I would like for you to do is pause the video and try those 2 values in your calculator, and you should see that we get this nice parabola, and we plot the points with our axis of symmetry, and hopefully you'll be able to draw yours. As I'm doing it on the tablet, it's always not quite as smooth. If you need to pause it, please make sure you do so. Now, as we take a look at this using a vertical motion problem, it says in lesson 9.1, we learned that the height is equal to negative 16t squared plus c. H is our height from the ground of an object falling at an initial time, and c at that time, t. It says if an object, if it is projected into the air, the initial upward velocity v has no additional force acting on it. So here is our formula. The height is equal to negative 16t squared, velocity times time, plus c, which is the initial height. It says this will give us an approximate height from the ground. And you're thinking, wow, this is kind of tough. So as we read this situation, during halftime of the basketball, the slingshot launches T-shirts into a crowd. A T-shirt is launched at an initial upward height of velocity of 72 feet per second. The T-shirt is caught at 35 feet above the court. How long did it take the T-shirt to reach its maximum height? That's going to be our time that we're trying to find. What is the maximum height? That is our height that we're asked to find. And what is the range of the function that models the height of the T-shirt over time? So what values? And you notice, you can see they're slingshotting it up from 5 feet. At the top of the next page, we wrote the equation. Negative 16, notice where they put the 72. The 72 was our velocity, and our start height was 5. And we left the t in our equation. So it says, how long will it take it to reach its maximum height? If we're looking at these questions, what is the maximum height and what is the range? First thing we want to do is look at our function. And in our function, a is equal to negative 16, b is equal to 72, and c is equal to 5. As we look at this equation, the first thing we need to do as we start off is we need to be thinking, we need to find our t value, which is the same as x, and that vertex point we have to find negative b divided by 2a. So if we are looking at ours, we're going to have negative 72 divided by 2 times negative 16. You want to put this in your calculator, negative 72 divided by 2 times negative 16, or negative 32. We should come out with a positive 2.25. So if we are thinking about this, remember, we want to find, this is the t coordinate of our vertex. And remember, our vertex is going to be located at h, comma, or at t, comma, h. So this first one is our t, that's our time, what we just found. So the question, how long will it take it to reach its maximum? 2.25 seconds at this point. Now, if we're looking at our vertex, we have the 2.25, that's our seconds, and we need to now find our height. How do we find height? We're going to go back to our original equation, h equals, I'm going to put negative 16, and then I am going to put in t, 2.25, I'm going to square it, plus 72 times 2.25 plus 5. And so I'm just going to this original equation and plugging my t value in. And if I put that in my calculator as I'm multiplying that, I should get h equals 86. So the question is, what is the maximum height? 86, and in this case we were talking about feet. 86 feet is our label as we look at that. The last part of the question says, okay, if we are looking at this one, what is, if we are looking at it, the range that describes the t-shirt's flight? So remember, how high did they start? The range started at 5 feet to, in this case, 86 feet. Remember, this is our height, so sometimes we could have h is less or equal to 86 because it could hit 86 feet, and it is greater or equal to 5 feet because it started out at 5 feet. Okay. On this next one, they're telling us the initial start point. They're telling us our velocity is 64, and it's caught at 35 feet above the court. And they ask us the same questions. What is the, how long does it take to reach the maximum? How far above the court is it? And what is our range of values? First thing you need to do is write the equation. So going back to the h equals, remember it's going to be negative 16t squared. Then we're going to take our velocity, which in this case is 64t, and the height we started at, which was 5. We are now going to be taking a look at our equation, and we need to find the vertex. So in our vertex again is going to be t comma h. We need to find t first. How do we find t? And what you're going to see is that I'm going to start this problem, and we're running out of time in the video, so you're going to see me starting it, and I also want to talk about the homework. So I'm going to start it, then I'll have you pause the video and you'll see it written out, and then I'm going to give you a couple hints on homework. Now as you take a look at this, what I want you to see is that as we solved it, I first found the t part of our vertex by using negative b over 2a. You will do the same thing in your homework. You will then replace that value once you get what the t is of your vertex into the original equation, into this black equation right here. And that's what gives you the numbers. So you are going to put in 2 squared, 64 times 2, you get the height is 69. So it reached the maximum in 2 seconds. That maximum height was 69. Someone said, why aren't we using the 35? Remember, that's going to be as it's starting to come down, and so it's coming down to 39 feet even though it was shot, or 35 even though it was shot from 5. So here is your high point at 69. Now on page 556 you're doing 20 to 29. Use your notes to help you. The quiz on T1 of what's the vertex, the minimum and maximum, we will look at that probably and take that quiz tomorrow. I want you to start on homework, but we will be taking the quiz tomorrow.